This is lecture 5 for week 1 of CS 1030. So last time we talked about functional abstraction, and this was this incredibly important idea of breaking up computer programs into callers and callees, where the caller uses some functionality that's implemented by the callee, and the whole point of this was to avoid understanding an entire problem at once, and to rather decompose the problem into small parts that we can actually think about in our heads at a time. So today we're going to talk about a different aspect of different sort of fundamental aspect of computer code, and this is something we call pseudocode. And pseudocode is a really important notation for communicating computer program related ideas to other human beings. So pseudocode isn't English text, that is to say it's not comprised of sentences and paragraphs, but it's also not completely a computer language. That is to say, generally speaking, pseudocode can't be executed directly by a computer. So what it is something in between these in the level of detail. And pseudocode is really, really helpful for describing computer algorithms to other human beings. So that's all it's good for. It's not good for describing computer programs to computers. It's a way to it's a way to communicate with other humans, and a way to also be more clear about an algorithm, just ourselves. And so the point of not making it executable is we don't have to worry about all sorts of details. We don't have to worry about the actual, minutia of making a computer program work. We don't have to worry about even picking a computer programming language. We're basically just sort of writing a high-level description of what happens, and then we'll translate it into a computer program later. And again, this is sort of a different sort of decomposition than functional decomposition. This is a sort of decomposition where we're first figuring out the algorithm in some sort of abstract sense, and then we can second translate that into a computer language. So one thing I don't want you to think is that pseudocode is some sort of a toy that we invented for CS 1030. It's not at all a toy. Working programmers at all levels of experience, people who've been working programmers for 20, 30 years use pseudocode all the time. And they use it, for example, on a whiteboard to explain a new algorithm to their colleagues, so the colleagues could see if it makes sense or if it's sort of, maybe it's a silly idea. So let's look at a really simple pseudocode program. So here we have a 3-line pseudocode program, and we're going to talk through what it does. So the first line of the computer program, the pseudocode program, says set A to 0. And in order to figure out what this does, we need to sort of know what different things in pseudocode mean. And again, since this isn't really a computer language, we're not talking about what it means in terms of a program. We're just talking about what it means as a convention among human beings, just in the same way that when we say the word 7 among human beings, we all know what it means. So this line says set A to 0. And so set is kind of a command. A is something we're setting, and 0 is what we're setting it to. So what actually is A? Well, A is a variable. And a variable is one of the most fundamental concepts in a computer program. Almost all computer programming languages have variables, not all of them, but almost all of them. And a variable is basically just a name for a value. So the variable A at any point in a computer program is going to have a certain value, and whatever it's assigned to, it's going to hold that value until the variable A is assigned again. And at that point, it's going to forget the old value, and it's going to get a new value. So here we're setting A to 0, and all that says is from this point on in the pseudocode program, A holds the value 0 until A is assigned again. So let's look at the next line. So the next line, of course, is going to set A to a different value. And so the question we're going to ask ourselves is, well, what does this command set A to? And it's a little bit confusing because A is here twice, and we have to understand that the A's play different roles. The 2 A's in this line play different roles. So what we're going to do is first look at the current value of A. It has to be 0 because we just set A to 0 in a previous line. Then we're going to evaluate this mathematical expression, which is A plus 1. So if A is 0, then A plus 1 has to have the value 1. So the value of this expression is 1, and that is what we're going to set A to. So before line 2 gets executed, and again, we're executing in our heads, A holds the value 0, and after it, it holds the value 1. So in the third line of pseudocode here, we're going to display A, and display just means show the value of A to a user or to somebody executing the pseudocode. And so what it's going to do is just print or show us whatever value A currently holds, and that's 1. So what are the 3 things we've looked at in this example that we can do with variables in pseudocode? We can use them in 3 ways. We can assign them. That's setting A to something that makes A forget whatever it previously was and hold a new value. Of course, we could also assign A to the same value that it was. We can modify A, which is basically just a shorthand for looking at the value in A and then setting it to something different. And we can also retrieve A. We can look at the value in A, and this is what line 3 does. We can look at the value of A without changing the value of A. So hopefully that was clear. So this is a pseudocode program. Again, this example here is too simple to convey anything useful to another human, but more complicated examples of pseudocode are how we describe algorithms to other human beings without getting them bogged down in the details involved in actually writing a real computer program. And again, working programmers use this kind of thing all the time. It's a really important tool in our toolkit. So in math, the equals sign indicates equality. So if two things are equal, they're the same for mathematical purposes. So for example, a repeating 9, 0.9, where the 9 repeats indefinitely, we say that's equal to 1, because for practical purposes, they're the same value. So unfortunately, computer programming languages have sort of taken the equal sign, and they often use it to indicate assignment and not mathematical equality. So this is a completely different use of the same symbol, and all we have to do is just sort of remember which use of the symbol we're using right now, and then we won't be confused. So in the same way that that a word like meat in English means two different things, it means animal flesh or encountering another human being, the equality sign in programming languages often means both checking for equality and assignment, and we can figure out which one it means right now just by looking at context. So here I'm just going to show some stuff I looked up on Wikipedia. This is how a whole bunch of different programming languages do assignment. And so you can see, for example, at the top that the Magic programming language uses the two less than signs next to each other to assign the variable to the value of an expression. And if you look down the list, other programming languages, and I don't expect that you've heard of all these or even very many of them, use different ways to indicate assignment. And all I'm doing here is I'm not trying to get you to learn learn the symbols that are used for assignment. I'm just trying to convey the idea that when you design a computer language, you can choose any symbol you want to represent the concepts, and different computer language designers have used different pieces of text or different notations to indicate the same thing. And it's just something you have to get used to as you write different computer programming languages over your time here as a student and over your course as a computer programmer. So let's talk about executing pseudocode. So can a human execute pseudocode? And sure, a human can. So our brain here is basically acting like a computer. It's not a very fast one. It's not necessarily a very accurate one, but it's, it works. So let's talk about how we can do this. So the way we typically execute pseudocode is we make some sort of a table. We could use, a whiteboard, or we could use a piece of paper or anything to keep track of the current value stored in each of the variables in our program. And this pseudocode program at the left part of the slide here contains only the variables A and B. So if we're going to do that, we'll basically just make a table showing what value A and B hold at what step in our pseudocode program. So after executing the first line of code, that is to say step 1, A holds the value 0, and we know that because that's what we set A to, and B, we don't know what it holds. We didn't set it to anything yet, so B holds, so at this point in the program here, B doesn't hold any particular value. So after setting B to 0, that is in the second line, so now we're here in the pseudocode program, now A has the value 0 and B holds the value 2. If we set A to A plus B, so now we're executing the third line of the pseudocode program, then we first have to evaluate the expression A plus B. So this requires retrieving the values of A and B, and we can do that by looking at our table. So A is 0 and B is 2. Adding them together, the sum is 2, and setting A to that sum. So after executing set A to A plus B, then you can see that A holds 2 and B also holds 2. If we execute the same line of pseudocode again, the result's going to be different, not because the line of code is different, but because the values held in the variables was different. So this time we retrieve 2 from A and 2 from B. We add them together to get 4, and we set A to that value. So now, after this line, at this point in the pseudocode, we can see that A holds 4 and B holds 2. If we do it again, then we can see that A holds 6 and B holds 2. So none of these lines except the second one set B, and so B doesn't change except after executing that step. So finally, if we display A, we retrieve the current value held in A at that point in the program, which is going to have to be 6, and that's what we would show to the user. So again, as I said in one of the earlier lectures for this week, computers get input, they perform computations, and they produce output, and that's exactly the kind of thing that we want to be able to show in our pseudocode. So let's talk about how we can get input in pseudocode. Well, we're making the rules here. It's just a sort of a fake programming language almost. So we can get values any way we want, and so we're going to use a word called get in order to ask the person running the pseudocode, and here running's in quotes because we're not really running it, but we're going to ask them to provide a value, and then display, of course, means showing them the value. So in step 1 of the pseudocode on this slide, we display enter a number. So the person who is running the pseudocode knows that they're supposed to provide a number. Then the second line of the pseudocode, get A, means take a number picked by the person running the pseudocode and put it in A. And then we display A. So of course here we just show them what they entered. So it's not a super interesting program, but we're just trying to make sure that we're solid about the concepts here so we can start doing more complicated and interesting things with pseudocode in the rest of the lectures for this week. Thank you.